Good morning. Anyone here actually speak Spanish? I don't. I've only lived in Seville for 5 years. I don't speak Spanish ever. Hello and welcome. Today my talk is about is boilerplate code really so bad? I'm Trisha Gee. I'm a developer advocate for JetBrains. I nearly forgot then. I got up at 4 this morning, so I can't remember my own name. And I mostly work with IntelliJ IDEA, so mostly what I do is I go around talking about Java primarily and how Java developers can get the most out of their IDE and out of the language. But JetBrains also invented Kotlin. So who knows about Kotlin? Loads of you. This is not an intro to Kotlin talk, I'm just using Kotlin for some of the examples. And who's using IntelliJ IDEA? Excellent. And the rest of you are using Eclipse? And some of you aren't using anything? I don't know. So the purpose of this talk is to talk about, is boilerplate code really so bad? We hear in modern languages, they're always reducing boilerplate code, and often people are moaning about Java and the amount of boilerplate code that's in Java. So I will give you the TLDR so that you can walk out if you don't want to see the rest of the talk. Yes. Boilerplate code is quite bad, and we're going to go through some examples of why, of when it can be quite bad. But also, as with everything in our industry, the answer is kind of, well, yes, it's mostly bad, but not always. And there are occasions when you're going to have to think about whether to make your code very terse or whether actually some extra code is needed to improve readability. And that's really what we're going to talk about. We're going to talk about code readability, because code is read more often than written, which is something actually a lot of employers don't necessarily understand. They sort of think that us as developers, we sit there writing code and that's what we do all the time. But often that's not really the case. Frequently we're reading code. It's either code that we've written, trying to understand it, code that someone else has written, so we're going to add a feature or find a bug, or just to get a feel for the code base. So Uncle Bob Martin claims that the ratio of time spent reading versus writing is well over 10 to 1. I'm not really sure where he got that number from, but it's Uncle Bob, so we'll believe him. But overall, I think we can say that we do tend to read code more often than we write it, by a large factor. And therefore, when we're thinking about writing our code, we should be optimizing for its readability. And that's what a lot of modern languages are doing. They're optimizing for readability. Let's go through a really silly, simple example, a hello world example. Okay. So let's write our hello world. When I'm using my shortcuts, the shortcuts will pop up on the bottom of the screen, which should tell you what I'm doing as I'm magically getting IntelliJ to do all the work for me. So let's create a new class. In fact, in terms of reading versus writing, you should be able to see sort of how many keystrokes it takes to develop this particular application. So I did Alt and Enter, so that's 2 keystrokes. I'm going to type main. This gives me a new class. Then I can do the magic incantation of PSVM, public static void main. That will give me a new method. And then I do a magic incantation of SOUT, SOUT. And that will give me system out. And then I will say, hola. And that's it. So a number of keystrokes, around about 20, to do a class which is 8 lines long. So in terms of writing, yes, it's a lot of code, but it's not a lot of keystrokes, especially the IDE will help you a lot with that. Similarly, for Kotlin, let's have a look at Kotlin for a contrast. We'll have a new Kotlin file. We'll call it main. This time with Kotlin, you don't need to declare a class if you don't want a class. You can just declare the function. So you can go straight ahead and say public static void main. And then you can say SOUT and do the same thing. And there's marginally fewer lines of code there, so it's a bit quicker to get started writing code. You don't always need a class for everything, and that's kind of how Kotlin thinks, is that in terms of it's supposed to be aimed at being a productive developer, so we don't always need to be super object-oriented for everything. But there is one final thing that we can look at in the Java world, and that is that's JShell. the REPL for Java. This came in Java 9, is obviously available in Java 10 as well. And this makes things even simpler. So I can say system.out.println, and I can say hello. Oops. I don't need a semicolon. This is Java, not Kotlin, and I don't need a semicolon. It's very revolutionary. So then, when I'm using the REPL, I don't really need anything. I just need to write the thing that I'm trying to write. So I don't need any class. I don't need a method. This is actually using the JShell console inside IntelliJ IDEA, but you could do the same thing from inside a command line, which, this being Windows, I can't resize the command line, so you can't see it when I type it, but it's basically the same thing. And I get tab completion even inside. The tab completion is not part of IntelliJ IDEA, that's part of the REPL. So I'm optimizing to a certain amount for my writing. I can write things fairly quickly. So that's a nice feature of Java 9, which allows us to prototype stuff quite quickly without having to do the full ceremony of writing classes, etc. So, where were we? Oh, I've started the presentation all over again. Right. So, in terms of the Hello World application, writing it is very easy when you're using an IDE like IntelliJ. Obviously, the other IDEs are pretty good too. Eclipse and NetBeans and all of them, I assume, have full code completion for this sort of thing. So writing is very easy to write it even when there's a lot of boilerplate. The REPL actually is marginally less easy to write for because I can't use my IntelliJ Live templates, but it's still very quick to write stuff in the REPL. But in terms of reading, I need to write all of this, and I need to read all of this to see that actually all I really care about is that I'm printing Hello World out to the console. So that's an awful lot of just rubbish getting in the way of me reading what does this piece of code do. And there's 8 lines of nonsense telling the compiler what to do and not telling the reader what it does. So I say that's fairly questionable in terms of readability. And from the Kotlin's a bit better because we don't have the class declaration and we don't have to go the full ceremony of saying system.out.println. But again, there's a certain amount of boilerplate in there. So it's better. And JShell is even better because I just have to say system.out.println. So weirdly, in my mind, JShell is optimized for writing because you just kind of write bits of code, and it's not really about reading because JShell is about experimenting. It's not something you're going to go into later and read it. But in this particular case, in terms of readability, JShell actually wins over the proper class files. So that's the best one so far. Let's look a little bit at declaring variables. We're going to dive into the history of Java a little bit here. So in Java 5, you used to have to say, basically map appears twice on either side of the equals, integer appears on both sides of the equals, customer appears 3 times, because I've also called it customers. And there's an awful lot of repetition in there just to create a new map. The IDE will help to hide that for you, so the IDE will just hide some of the duplication, even if you're using Java 5 or Java 6. Java 7 made that official, so with a diamond operator, we don't need to duplicate the declaration inside the brackets because there's no need to say it on both sides. You just say it in one place. And with Java 10, we can get rid of saying anything on the left-hand side. Note, however, that you still need to declare the types somewhere, so you can't just get rid of the map and the integer and the customer from both sides, because then the map doesn't know what type it is. So I can't say I've got a hash map with the diamond operator because there's nothing on the left-hand side to tell me what should be in the diamond. So the types have to appear somewhere. But over time, Java is becoming less verbose in terms of declaring these things. And from a readability point of view, I can see I have a map of customers which maps an integer to a customer. So that's quite nice. It's nice and succinct. And Kotlin goes even further and says, well, why do you need the new keyword and why do you need the semicolon? Because people hate semicolons, right? Who likes a semicolon? Who hates them? Who hasn't had coffee yet and doesn't care? Great. So yeah, there's a lot of hating on semicolons, but I just get my IDE to complete that, so I don't really care. But Kotlin, you don't need the semicolons. So that's kind of about as short as you can get the Kotlin one. So the Java one, we get fairly decent readability out of Java. Kotlin goes a bit further, just removes all of the new keyword and the semicolon, and so that kind of reduces it. Is that the best thing that we can do in terms of declaring our variables? And I would say it's not necessarily always the best thing to do. The shortest thing is not always the best thing to do. So let's take a quick look at uses. I'm going to say var in Java because it's new in Java. It came in Java 10 in March. Who's using Java 10? Well done. I did not expect that response. It's like 4 of you. Who's using Java 9? 1 person. 2 people. Great. Java 8. Everybody else? Pre-Java 8, earlier than Java 8. Okay. I think you might have put your hands up twice. That's fine. There's more than one project. Who's on Android and is stuck with Java 6? No one. Okay. I don't have to apologize for Android people then. So the rest of you who aren't using Java 8, you have no excuse. I understand the Android people, but other people know you should be on 8 by now because everything else is like not supported by anybody. So Java 10, we got the addition of the var keyword in Java 10. So what I can do is I don't have to declare the types like I showed you earlier on. So let's say we have a piece of code like this. Let's say we have a factory which creates as a customer. And I'm looking at this code, and I refactor it, and I add a static import for create, because I'm like, I want this to be smaller. So I say create, and then later on, I'm using Java 10, so I say, OK, I can actually say this is var. So I add var, and then suddenly, this code means almost nothing. I don't know what I'm creating. I don't know what C is, because I gave it a stupid name. And I've added var to it, so there's no type information there at all. Now, it's worth noting, because some people don't really get a bit confused over this, that declaring it with a var doesn't mean it doesn't have a type. It is still of type customer. It's just that it's not there in the written thing, so it's just syntactic sugar. So it still has a type of C, and if you're looking at it inside your IDE, it will still tell you it's a customer. But if you're reading it, let's say in a code review tool, which doesn't support the ability to inspect types, or you're reading in production and in Notepad or whatever, you can't see what this is. So in a case like this, you're not going to want to go to the most terse syntax, because from a readability point of view, it's questionable at best. So yes, so removing all boilerplate is not necessarily the aim of this activity. Let's have a look at data classes next. This is my... when I started creating lots of data classes, this is when I started to think, oh yeah, maybe Java, maybe it's not awesome for some things. Let's create a customer. Let's create a new class. I'll call it customer. And I'm going to give it a, it's going to have a, let's not say final, private int age, and I have a private string name. And then, obviously, I need to create a constructor, which has those 2 things in. And then let's say I want getters. I'm going to make these effectively immutable, so I'm going to create getters but not setters. So let's add some getters for both of those. And then I'm going to add equals and hash code. And then, because when my tests fail, I want to be able to understand what's going on, I'm going to add a toString. Okay? So this is a simple bean which has 2 fields on it, and it's 52 lines long. It didn't take me long to create it because I use IntelliJ IDEA to create all my stuff for me, so writing is not the problem here. But when I come back to this and read this, I just have an awful lot of noise here, which I don't really know if this is business logic. I don't know whether this is a generated method. I don't know whether the generated method has been overridden in some way, or if I changed it slightly, or if I manually created it. I can't tell by reading this what these things are and what they mean. In Kotlin, if we have a data class like this, I can say, give me a Kotlin class, customer. And then I can just say I've got a val of age and a val of name, which is a string. I don't need my curly braces, and that's it. So that's exactly the same thing. And it's much more, you can sort of see at a glance, what is this? This is a customer, it has 2 fields in it. And the fact that it's val and not var means that I can't change them. And I have a constructor which takes those 2 things in. And it has all my equals, hash code, toStrings, everything by default there. Now, if I want to override any of that behavior, I can still override that behavior. And then when I look in here and I see method bodies, I know that the behavior has been overridden and it's non-standard. So when I come to read this class, I can see much more clearly what it's trying to do, what the business logic is, what the unusual logic is. So it's easy to write the Java class. I just generated it. It was easy to write the Kotlin class because it's just one line of code. From a reading point of view, I think we're going to have to give Java, like, I don't know, a D-, must try harder. It's not really ideal. And reading Kotlin, of course, the only stuff in there is the stuff that you need to know. It's a data class, and it has 2 fields in it. So I would say that's a massive win for Kotlin. By the way, I'm not trying to sell anyone on Kotlin. I work for JetBrains and we created Kotlin, but I'm a Java person and I feel super defensive about Java. So anytime anyone says, Kotlin's amazing, I'm like, well, Java's okay. It's getting better. But every now and again, you come across something like this, you're like, yeah, okay, it's quite a bit better. And it would be nice if I could use these things. But Kotlin is totally interoperable with Java, so theoretically, I could go in with some of my projects that I'm working on this year. I'm going to start by replacing the stupid beans with data classes, so I can see straight away which things have like no interesting functionality in. And there is discussions around data classes for Java. What should they look like? How should we deal with them? Should they come to the language? And data classes is one of those things where everyone's going to have an opinion. They're implemented differently in different languages. So are they going to do a Kotlin-style one, a Scala-style one, something which is different, because Java always does something which is slightly different, probably because of backwards compatibility. So if you're interested in that, then do take a look at that. This was a post about what they're trying to do, and then there's things on the mailing list so you can get involved if you're interested. Casting. We shouldn't be doing casting in our code because we should have all the right types everywhere, but that's not necessarily the case when we're at the boundaries of our system and stuff comes in and we don't necessarily know what shape it is. So casting in Java is kind of icky because you do an instance of, so if you don't know what type it is, you can do an instance of and then you do a cast, which is kind of dumb because you just said, I'm inside an if block which says you are an instance of view. Why do I have to say this is an instance of view? It's just kind of pointless. In Kotlin, if you said, is it a view, then it's highlighted in green in there, which you can't really see very well. But inside that if block, IntelliJ has highlighted in green to say, this is now effectively a view. You can deal with it as if it's a view. You don't need to cast it. So that's quite nice. And then that's the null-safe way of doing it. And then you can also shrink that right down. So in Kotlin, I will talk about this in a minute, about nulls, but in Kotlin, generally, you don't have nulls, but you could be talking to Java objects which could be null. And so then if you're trying to figure out whether it's null or not and what to do, you're going to see these question marks all over the place. So let's go on and talk about nulls in a minute. This JEP is about, so JEP is basically a suggestion for features to add to the OpenJDK, to Java. And they're always talking about stuff that could go into Java next. So this JEP 305 mentions the problem with casting and how you have to cast it multiple times, even though you already know what shape it is. So that's something to follow if this is a problem that you're interested in. Let's talk about nulls. I'm going through this much faster than I expected. Java and the null pointer exception. Who started programming in Java as their first language? Quite a lot of us. In the first, and regardless of whether it was your first language or not, how long was it between your first line of code and your first null pointer exception? Like 10 seconds, maybe? And I remember my first week of programming Java, and I came from Pascal, and I just kept getting these null pointer exceptions all the time. I'm like, what does this mean? What is this? It makes no sense. And of course, you start to learn that anytime you start chaining method calls, anywhere along there could be a null. So you might see methods like this, which are going to do null guards all over the place. So I pass in a customer. I'm going to check to see if the customer is null. If the customer is not null, I'm going to get the customer name. And if the customer name is not null, then I can check something on the customer name and then do some sort of logic somewhere along the line. And that's kind of tedious. One of the best ways to deal with this, of course, is to have domain objects, certainly inside your core domain, that don't have nulls, because you should know inside the core bit of your domain what your values are and what's allowed and what's not. But that's not always the case at the edges. If you're looking at a customer object which came from a database or from a user or from a different system, sometimes you just don't know what's been populated and what's not. In Java 8, we got optional, which is supposed to make the null problem go away. I'm going to make Stuart Marks very sad because he's constantly telling me how to use optional and making me better with optional, and yet I constantly struggle with it because it's not what I thought it would be. It's not the magic fix for nulls, for a start. So this is one way to do the above code with optional. So I can do a flat map and a filter and an if present, and that way I don't have to do any null checks, and I can do it in a more functional way. I can call all these methods with dots without getting a null pointer exception. It's kind of a bit interesting because in this case, I'm passing in an optional parameter, and best practice is not to do that. So this is where optional becomes a bit like, well, when should I use it? When should I not? I shouldn't really be passing optionals around because I should either know whether it's null or not. I shouldn't be using this as a catch-all to pass stuff around. But it is a marginally prettier way of doing the null check thing. It's just kind of, I don't know, I'm a bit torn about optional. Is anyone happy with how they use optional? Is anyone, kind of happy. Is anyone really confused about optional? Lots of people, 4 people. And who's not using it at all, and who's not using it at all? And the rest of you just don't want to put your hands up, that's fine. So optional is Java's current answer to the null problem. It's generally, you should be using it on return types. So if I'm going to get a customer from a database, then I get an empty optional if it doesn't exist. That's much more clear. It's not really used for these sorts of circumstances. It's not used everywhere. In Kotlin, if you've got a customer object in Kotlin, the idea is you don't have nulls in there at all. Null is a bad thing. We just don't use null to represent anything. A customer will always have all of those values. If, however, Kotlin is talking to a Java object, which of course could have null values, then I can use this question mark to basically chain my way through customer name starts with, and if there's null anywhere there, it'll just ignore it and just won't follow the chain through. So it's a bit of a more succinct way of doing the first example where you're doing the null guards, the ifs. Okay, switch statements. I didn't want to show this example because I feel like we shouldn't be using switch in code. I feel like it's just a smell. It's a sign that something's gone wrong. But then I thought it through. I looked through a lot of code bases and realized, of course, that you use switch statements quite a lot, again, at the edges of your system, taking in input from users, taking in values from databases, from other systems. You don't know what's there. You want to turn probably a string or an int or something simple into one of your domain types. And so at the edges of your system, you'll see this sort of thing. I've seen this sort of thing a lot in Android code, because Android code, obviously, the user is giving you stuff, and you have to inspect it and do something useful with it. So in Java, a switch statement, you might have something like this, and you have to turn the object into an int or some type that you can do a switch on. You have to have a mutable variable if you want to assign some value to it, because you're going to go through a series of ifs, basically, and decide whether to assign something to it. You might have duplicate case statements, and then if you've got anything more complicated than does it match this specific thing, you have to put it in the default block with if statements, which seems a bit clumsy and tedious. In something like Kotlin, you can actually mix these things up. So you can assign the value that comes back from the when to an immutable value. You can say I've got specific values I want to match against. I've got ranges I can check against, and I can even do more complicated checks like is it an int to begin with. So I don't need to do any casting or any forcing these things into a specific type. It will just fall through if it's not the right type. So when I see examples like this, I can see why Kotlin is widely used in something like Android, because the sorts of things that I see often in Android applications are just made a lot easier in Kotlin. And this is a question that's being asked around Java. How can we do this in Java? So there's two JEPs, the previous one about pattern matching and turning switch statements into expressions so they can return types. And this is something that is being worked on in Java, the language. So what I think is really interesting about a lot of these examples is Java is not the language that we thought it was once. It's not just full of crufty, boilerplate, nonsense, nastiness. It is evolving. It has evolved a lot over the last few years. And now that Java is being released every 6 months, which isn't too terrifying at all, every 6 months, we're getting new features every 6 months. And these new features are going to change the way that we as developers write our code and read our code. And so some of the things that we don't like about Java right now are being worked on and will be released in a version of Java in the near future, probably nearer than we expect it to be. So we talked a bit about ranges in the switch expression. So you can define a range in Kotlin. You can do the same sort of thing as this in Groovy. In Java, you can do an int stream, which is a range, which is not quite the same thing because you can't really do anything cool with your int streams apart from do stream operations, obviously. But you can't use it in switch statements. You can't use them. You could pass them around, but you're passing around a stream, which is a bit seems a bit big just for something which represents a range of numbers. Default parameter values. So in Java, if you want to create some defaults for a method, then you're going to use method overloading, probably. That's the way to do it in Java. And this is a bit icky, really, because you have 3 signatures for the same method. And in Kotlin, you can have one single method signature, and then you can define what the default values are. So if you don't pass in a value, this is the default value. And this, from a readability point of view, this is amazing, because I can see, when I look at this method, I can see that it takes 3 values, but 2 of those parameters have a default value. So if you don't pass that in, this is the value I'm going to get. Now, in the Java world, I'm going to have to navigate through those 3 methods and hope that they're kind of co-located so I can see them next to each other, so I can see that the default values are an empty string. So the Kotlin way of doing stuff definitely makes the readability, definitely improves the readability. I can see at a glance what the default values are. The other thing about the method overloading is that it leads to subtle bugs. Can anyone spot the deliberate mistake? Is anyone still there? No. And this is partly a function of the fact that method overloading, all 3 types are the same. They're all strings. But here, I pass prefix and message when the actual method is message and prefix. So I swap those 2 parameters around. And that's kind of, it's very easy for subtle little bugs like that to creep in when you're using something like method overloading. Collections. So with Java 8 and Java 9, collections got so much more interesting, useful, and generally easier to work with in Java. In previous versions of Java, you could always create a predefined static list by saying arrays.asList. And what we probably didn't realize is that that's not really what we wanted. We actually wanted an unmodifiable list of arrays as list, so I needed to wrap it in something else. Arrays.asList gives you a list that you can't add elements to, but it turns out you can actually alter the elements inside that list, which is something that, as I speak to more and more developers, lots of people didn't realize that. So it wasn't the immutable collection they thought they were getting. So in order to create an unmodifiable list, you have to do this, which is a little bit ugly. In Java 9, this became a lot easier. So you just say list.of. And that's nice, it's shorter, and it gives you an unmodifiable list. With Kotlin, you say list.of. That's the same thing. And so in many ways, this is basically the same code. Obviously, in Java 10, you can replace the list customer Java with var, so it looks exactly the same pretty much as the Kotlin version. However, there's a subtle difference which I didn't realize till I started working with both of these examples. The list in Java is immutable, but it throws runtime errors if you try and do anything to it. So if you try and add anything to it, if you try and alter anything, it gives you a runtime error. It doesn't give you compile time errors. Whereas the Kotlin list is of type list, but the Kotlin list type is read-only and only has read-only methods on it. And if you want a mutable list, you have to return a mutable list. So again, from a reading point of view, Kotlin, well, you can't see the type here because I obscured the type. But let's say we made the type more explicit. Let's go to collections. And then let's say we make the type more explicit. This list, I can see I'm getting a list back. And the list, I'll do my quick documentation, it says methods in this interface support only read-only access to the list. And so when I'm reading this code, I can see that this list is immutable. And there are no methods to even call to mutate this list. Whereas in Java, it will tell me that it's immutable, but it won't give me any compile time errors if I try and add anything to it. Okay, Lambda Expressions, the exciting new thing that came in Java 8. Probably the main reason that people moved to Java 8 is streams and Lambda Expressions. We had lambdas in Java. We didn't have lambdas. We had a way to pass around behavior, which was anonymous inner classes, which, when we're talking about boilerplate, this is basically the ultimate example of boilerplate, because there's just no need for almost all of this code. So in Java 8, we can just pass around a Lambda expression. I've purposefully let that go off the edge of the page because I couldn't be bothered to wrap it around. But you pass in, you say, I've got an event, what do I do with it? And you just give it a piece of behavior. Kotlin goes one step further, which is that if you don't need that parameter that goes into the Lambda, in our case we have an event, but we're not using the event, then I don't even need to put in the event or the arrow. And in Java, in a later version of Java, who knows which version, we'll be able to define that we're not using that parameter. So again, from a readability point of view, I put an underscore for that parameter to say, I'm not using this. It's just not going to be used inside the Lambda body. There. While we're on the topic of Lambda expressions, I think Lambdas are something that we can kind of learn to read. We haven't been using them much as Java people, so it's unless you've been working in other languages. If you've been working in Java for a long time, we haven't been using Lambda expressions all that much, but we can kind of learn to understand that this is a piece of functionality that we're passing around. One of the things I really struggle with in Java, though, is a method defining a method that takes a Lambda expression. So here, what we've got is, I want a method called get, and I want to be able to pass a Lambda expression into that method. And what I can do is I can create myself a parameter which is of type root handler Java, which is a functional interface. And this annotation functional interface says you can use this as a Lambda. You can implement this as a Lambda expression if you want to. A more idiomatic way of doing this is using the built-in functions, built-in functional interfaces from Java. So instead of using our handler, we use a by consumer, which passes in a request Java and a response Java. And I'm like, when I first started using Java 8, I was like, what is a by consumer? What does this do? If you look at implementations of by consumer in the JDK, there's only one, and it's an inner class in something else. And so you have zero help from the method signature to understand what this is. What does this get thing do? And what is this by consumer that I have to pass in? It makes no sense to me. So from this is from a writing code point of view. If I'm writing something which calls this get method, I'm kind of stuck. The only thing that really helps me is my IDE, of course. So if I look for, let's have a look. So let's say I want to, I don't want to run that. If I want to call my get method with my by consumer, then I'm going to call get. I'm going to give it, it says I need a path, so I'm going to give it a path. And then, like I said, it says, oh, no, that's cheating. It says I'm going to have a by consumer with request Java and response Java. I don't know what that means. And I might be tempted to say, okay, let's have a new by consumer And then it gives me an anonymous inner class, and then I'm like, what am I doing here? What century do I live in? I don't even know what this is. And that might be an easier way to get to grips with Lambda expressions as Java programmers, because we can kind of get our head around this. Okay, so I've got one of these, and now I have to implement something which uses those things. Or I can use IntelliJ's smart completion, which just says, you're going to want one of these things. And so I go, okay, fine. So what you're actually asking for is a Lambda expression. Why couldn't you tell me what you wanted was a Lambda expression? It makes no sense to me. So other languages, like Kotlin, they define on the method declaration that this is going to be a Lambda expression. You're like, oh, right. That makes a bit more sense. And so it's from a readability point of view, I can read that method declaration and go, that takes a Lambda expression. And these are the types. Makes way more sense. Navigating collections. So this is another way of saying lambdas and streams. So now we've looked at Lambda expressions. Java 8 gave us a streams API, which is quite a nice way of doing complicated stuff on collections, assuming that we have big data and we want to do complicated stuff on collections, which not everyone does. But let's say we have a list of customers, and what we want to do is we want to filter out, we want all the customers whose name begins with A, and we want to get their email address, and then we want to add that into a new list for whatever reason, and that's what we want to do. And so this is how we do it with Java 8. With Kotlin, we can actually remove some of that code. We can say, okay, we don't need a stream, we don't need to collect, we can just simply do customers.filter, and we have our Lambda expression with our customer. And then Kotlin says, well, actually, if you've just got one parameter for your Lambda expression, then you can just use the magic incantation of it instead. Like I think Groovy does the same thing. And so I can just reduce all of that, and I say, look, I can see in the Kotlin version, when I'm reading it, I'm going to filter for everything that starts with A, and I'm going to get the email address. And that's going to give me a list of emails. And so that's a little bit more succinct, and it does exactly the same thing. No, it does not do exactly the same thing. And this is an interesting thing about boilerplate or lack thereof. In actual fact, this second version of the Kotlin one, this does the same thing as the streams operation. Because the one without the stream, or the one without the sequence, does eager evaluation. So it takes the customers, and then it does the filter of all of them, and then it does the map. And so it's going to do each of those operations in sequence. Now, the whole point about the Streams API is that it's lazy. So you give it a recipe, do the filter, do the map, do this, do the other, and then when you call the terminator, then it will put together everything and try and do stuff in as efficient a way as possible. It might do some optimization there. So it should do everything in a single pass, whereas the first Kotlin example does things in two passes, the filter and then the map. In order to make use of sort of lazy evaluation, you need to say as sequence, and then you need to call the terminator, because otherwise it doesn't know when to do the thing. So you still need to do the to list. So we can quite often get confused about what's really boilerplate and what is actually intended, what is going to change the behavior. In this case, removing the as sequence and the to list will change the behavior, change the performance profile of this code. It might not matter, because it might be that for small collections, that's fine. The performance is exactly what you want. But you need to be aware of that these two things are not the same thing, and the as sequence and the to list are technically not boilerplate. They're kind of important. So, in summary, let's summarize what we've seen so far. The elimination of boilerplate can improve readability, and it should allow you to focus on the business logic. So, for example, the data classes is an example I really like about Kotlin, and I feel sad for Java. I can see here exactly what the business requirements are. I have a customer with an age and a name. And in Java, I can't see what here is business logic and what is just plumbing. On the other hand, not all so-called boilerplate is actually boilerplate. Sometimes when you remove what we thought was boilerplate, you change the meaning of the code. For example, if you remove the sequence and the to list here, you're not removing boilerplate, you're actually doing something different. So we have to be careful about that. Less code is not always better. Now, we know this because we're Java people, and people are always moaning at us because our language is verbose. And we're like, well, that's fine. We like long method names, and we would prefer to be able to see too much and then ignore it than to not see anything and not understand it. So we know that less code is not always better. Sometimes additional code can improve the readability of the code. For example, this is a horrible piece of code. I really hope none of you write something like this. It can be improved simply by having a better variable name if we have control over that. But we don't want to go full on just removing everything because obviously shorter is more readable is better. That's not necessarily the case. I managed to sneak an example from Groovy. I've been doing some testing in Groovy in the last couple of weeks, and it has its, I'm not going to say downsides. There are pros and cons to every language, but I do like Groovy for testing. And here we have a lot of boilerplate. We have an annotation, which is subject, which doesn't do anything other than tell us that this is the thing I'm trying to test. And then we have boilerplate saying given, when, and then. They're not really boilerplate because they are the thing which tells Spock that this is a test. But from a readability point of view, this is amazing because it genuinely helps the reader see, okay, this is all set up, I can more or less ignore it until I need to care about it. The thing I'm really testing is the bit under when, and my assertions are under then. So this is verbose, but super readable and super useful. It's a specification, and that's one of the things I like about Spock and Groovy for testing specifically. Anyone who wants to do this in Java, go ahead and write a framework that does this. This would be amazing. But so far, Spock is the best one I found for this. Readability is subjective. It's actually, there is no one way of measuring readability. We can't do it by saying, fewer lines of code is more readable, shorter things is more readable, or even more verbose stuff is readable. And it's often related to familiarity. So what is readable for a beginner programmer is not the same as what's readable for a very experienced programmer. People who've worked with languages like JavaScript might find some bits of Java more readable or less readable. People who've been working with streams or languages which support map-reduce type operations might find this readable because it does say, I'm doing a filter and a map, which is changing from one thing to another, and then I'm collecting it into a list. But people who've been doing Java for a long time might simply find the for loop with the if statement just that much more readable because that's what they're familiar with and that's what they've been doing all the time. So if you're trying to optimize for readability, you need to understand what readability means for your team and the people who are actually going to be reading that code. And so modern languages offer the option to reduce code. And by modern languages, I'm not saying, oh, Kotlin's much better because you have less code to read and write. I'm saying that Java is actually evolving pretty quickly as well. And if we are using more recent versions of Java, we have the opportunity to take advantage of some of the new features, like var, like list of, like streams and Lambda expressions. And these things are coming into the language, and Java is evolving as well and will continue to evolve. So these modern languages offer us options to reduce the code that we are writing and consequently reading, but we need to think about whether that really will make the code more readable or not. And that is the question. When we're writing our code, is it more readable to me? Is it more readable to the person who's going to come and support this? Is it more readable to the team? And what are those criteria? Who are my team and what will they find more readable? That is it from me. Any questions? Yes?
Hi, Trisha. How do you feel about using libraries such as Lombok for code generation or boilerplate?
Yeah. So how do I feel about using something like Lombok, which reduces a lot of the boilerplate from Java specifically? Lombok is really nice, actually, specifically for things like the data classes. The reason why I didn't put it in the presentation is because I quite often like to focus on core Java. But I'm definitely seeing more and more people using Lombok in their libraries because, and especially if you're using things like Spring Boot, because you can use that in there fairly easily. And it's nice because it just reduces a lot of the noise and does stuff for you. There was the problem with using external libraries of any kind is that they have to keep track with the language. So there was a small period of time when Lombok wasn't usable with Java 9. It is now usable with Java 10. But the more libraries you introduce, the more dependencies you introduce, the more complexity you also introduce in maintaining your code. But I don't have a problem with Lombok specifically. Code generation, though, is always a bit of a tricky thing, right? Because code generation, you've got another level of indirection. You don't really know what generated the code. You don't know what's going to break that code generation, and it leads to its own risks.
Congratulations.
Yeah, I can hear.
Okay. Congratulations. Very good talk. As a Java programmer, I was trying to move to Kotlin. But as we know, we have differences of syntax, so it was difficult to understand a lot of things. To start with, why does Kotlin has the variable type as the last part? Because in Java, we have it as the first part.
Right. So why is the type after the name instead of before the name?
Right.
I don't know the answer to that question. I think the answer, sorry, the original part of that question was like, Kotlin can be not as readable to Java developers because there are some things which are a bit weird and backwards. And yes, I assume that it's because you don't always need the type. And so if you're using var and val, then you don't need the type. But yeah, I find that a bit backwards when I'm trying to write my data class and I say val, age, int. It's a bit like, my head is aching. Yeah, there are some things there. One of the things so I haven't done lots of Kotlin yet. I mostly just keep getting exposed to it by colleagues who are trying to force me to learn this language. And I'm like, I spent 20 years with Java. Like, I'm a bit too old to learn new stuff. But one of the things that helps is, obviously, if you paste Java code into a Kotlin file in IntelliJ, it will do its best to convert that code into Kotlin. Of course, just don't take that at face value and do have a look through it, make sure it hasn't done anything stupid.
Thanks. First, congratulations for the presentation, Trisha. It's been
Thank you.
really informative. About the question from the guy, I can't remember the name. I've been involved in discussions about that with Ceylon team. I contributor for Ceylon and with Colin teams. And I can add a comment here that is putting the restriction on the behind of the type comes from the idea when designing Kotlin that they understand it as variable is something. So this natural language of saying this is that represents on the code as this putting the type after the name. While in Java, while in Ceylon, when other languages understand this as this variable has the restriction on the type being integer, being whatever it is. So the restriction is presented like putting it before the name of the variable. It's just adding like that. But in Kotlin, well, understanding the variable is something that being a pertinence on the type, they prefer it to put it afterwards. That's my understanding, at least, and well, that's the output of my discussion with Kotlin guys.
That's kind of interesting, I think, that from a natural language point of view, saying age is an int rather than int age makes more sense. And again, it comes back down to the point of readability, understandability is often linked to familiarity. So for those of us who are used to things being, I have an int and it happens to be called age, doing it backwards feels very odd. But for perhaps new programmers, it might be much more natural to be age, it happens to be an int. But it's an age, so I can make certain assumptions based on that anyway.
Completely agree.
Any more questions? No? Great. Thank you very much.